Hello and welcome everyone. On site here for the first time since 2019, back in this room, and everybody joining us online on Zoom. My name is Dennis Cohen. I am a postdoctoral researcher at the MZES and lead organizer of the MZES Social Science Data Lab. The Social Science Data Lab is an event series here at the Mannheim Center for European Social Research that provides a platform where early career researchers, scholars can present tools and methods for the collection, management, analysis, and visualization of data in the social sciences. It's organized by myself in collaboration with my colleagues from the MZES Data and Methods Unit and with the support of our research assistant, Andreas Küppner. Today's event is chaired by Camille Landesvatter, Paul Bauer, and Leon Behrens. And the remaining panelists are Lukas Isermann, Chung-hong, Domantas Undzėnas, and Sohnius. Camille, Paul, and Leon, seated on the right of our panel here today, are the co-editors of an impressive collaborative open science effort, an online book project that provides a collaborative review on the use of APIs in the social sciences. Lukas, Hong, Domantas, and Marie, seated on the left of today's panel, are contributors of chapters in this book project. To briefly introduce the topic of today's roundtable, APIs, or in long form application programming interfaces, are technologies that include a set of tools that allow researchers to send and receive data through a documented interface. They are increasingly used by social scientists for the systematic retrieval of data that is made available through those APIs. Today's event will be divided into two parts. First, the current three editors of the collaborative review will introduce their project and the chapters in general terms. And in the second half of today's event, they will discuss various questions surrounding APIs, including use cases, opportunities, as well as limitations that APIs bring for social science research question in conversation with the chapter contributors. In terms of the logistics for both our on-site audience today and our online audience on Zoom, you may ask your questions at any time. On Zoom, like I said, you may either raise your hand, in which case we will wait until it is convenient and ask you to unmute yourself and speak, or you can post your questions in the chat, in which case I will read them out for you. My job today is simply monitoring the Zoom chat. The moderation will be handled by the three co-editors of the collaborative review. Thank you so much for that. Thank you all for being here, and to our audience members. I look forward to the great presentations and discussions. And the floor is yours.
Thank you so much, Dennis. Hi, everyone, also from our side here. So I don't think I need any further introduction. You have heard our names already. I guess we are all very excited to be here today and also to have the honor of beginning the social science data labs in this semester. So thank you very much, Dennis, and to the others in the team. Yeah, this is a roundtable that the three of us organized. It concerns the APIs and, more importantly, the collaborative review that Paul originally founded, and now also Leon and I are working on it with many contributors, which for the four of them you can see here already. And first of all, for today, I would like to introduce you to the structure of the event. Dennis already told you that we have like two bigger parts. So the first one is really where Paul, Leon, and I talk a bit about APIs in general. This will be done by me. I will keep it very short, but only that we are on the same page, so to say. Then Paul will also show you the collaborative review in the web. Then we have some technical details shown by Leon. And then we would move to the second part, where we introduce you to individual chapters in the review, which is mainly done by our four panelists. And there you can see some examples of APIs that we include there. And then lastly, this is for the second half of the event, we would like to jump into the discussion with our four panelists and discuss different questions about APIs and how to use them in social science data research. Yes, and very important, we have plenty of time for questions from your side or from the Zoom audience. So feel free to jump in at any point given, and maybe especially for the last part, feel free to engage with us if you have any questions or simply comments or whatever comes to your mind, but also no pressure. So let's see. Okay. I would like to start by giving you some very, very basic information on APIs, and then Paul takes over. The definition I came up with kind of for APIs is the one that Dennis read out to you already. So what we can say is that API, short for Application Programming Interface, is a technology that includes a set of tools allowing users, so us, to send and maybe more importantly, to receive data or functionality through a documented interface. So this is kind of the starting point. Here we prepared a slide with a bit more of background on APIs. So where do they come from? Where are they heading? What are famous examples? So in my view, probably most of many famous APIs that we see nowadays they were generated in the context of Web 2.0. So the web as we know it, with user generated content, with social media and so on. And here we have those three big examples of YouTube, Twitter, and Facebook. YouTube and Twitter were founded in 2005 and 2006. And also in this very first year, they published the API, or first API that was available for the public to receive data from that platforms. Second or third, also Facebook API. Facebook was founded in 2004 and provided their first publicly available API in 2006. So a long time ago. Nowadays, we observe an increasing number of API-based research in social science disciplines. And from what I read so far, most of the studies use them for data access, so for data collection. Some examples also include very innovative research questions. One example is maybe from Paul and me. No, that's too far, but we are using Google APIs for instance, for named entity recognition and so on. So you could use those APIs to make very non-traditional or more newer approaches to manipulate your data, for instance. But we will see some examples later. Most importantly, I want to say that APIs allow us a very flexible and customizable access to data. So what we had to do before, or still do, is partly download or scrape a very bulk of data, which oftentimes is very unstructured or contains a lot of data we don't actually need. If you correctly use an API and know how to use it and have read the documentation and so on, you could retrieve very tailored and customized data in a structured format. Yeah, so this is kind of the motivation we had, I think, also for the APIs to have a closer look at them. Short example, I wanted to show you a snapshot of the Twitter website. So what they do is they explicitly mention academic research as a target group for their API, which I guess is very interesting. Okay, now with this brief background, I would say we show you our website project, and I would switch to our website probably.
Yeah. Yeah, so a quick few words on this starting point of this project. So basically that was a seminar on computational social science, and the seminar had the objective to introduce students both to machine learning methods but also to new types of data, and often we get these new types of data over APIs, and obviously also the students should apply these methods and use and collect the data themselves. And then what we found out that it's actually not that easy to connect to those APIs. Yeah? And that's, the idea was born that we have to write these little introductory things ourselves. And then we basically started with a Google Doc where we had like 20 students working together on this Google Doc, writing their chapters. And then we had basically some review system where teams of one chapter would work, would give feedback to another chapter. So there was some pedagogical ideas behind this. I think Leon was part of that. And actually, from the start, at the back of our mind, we had this idea that we might be able to open source that and develop this into a bigger project. And that's actually, so one of the fundamental aims is basically to give a quick access to these APIs, a quick explanation. And maybe we can open, so we now have this website, and if you just open like one chapter, so essentially kind of they always, all of these chapters, they follow the same structure. So yeah, so kind of the first section is what kind of services or what kind of data does the API provide? Then the second is the prerequisites that you need to fulfill. And this, for instance, could be that you need to make an account with Google or with Twitter. Then there's kind of a little section on a simple API call. And this was kind of the idea that in principle, you can access the APIs through your browser. And it should be, where possible, it should be kind of a URL that you can put into the browser to directly access the API in your browser and then to get back some data. And then there's like the next section essentially introduces, can you go this down? Yeah, basically then discusses how to access this API. And then in the next section, if you scroll further down a bit. Okay, I think this is kind of delayed. Yeah, so I think what people see online is a bit delayed here, but it's visible now. It's basically a section introducing how to use that API from R. Yeah, that's specifically a section focusing on R. We also discussed whether we basically could add code examples for Python as well. Now we have this website, and right now I think we have between 30 to 50 visitors a day, which I think it's not like a massive number, but consider that it's kind of aimed at social scientists. That's kind of a nice number, and it's growing steadily. And I think part of that is also that in the last section, so you can see that on the left, on the down left, we also always provide social science examples, basically to push the readers into that direction where they can already see how these APIs have been used in social science research. So that's what we have so far. So it's really meant to be a collaborative project where everyone can contribute. And it was a really rewarding experience also for us. So I got to know people like Hong, who then joined the project once they saw it online, or another one is Markus Konrad, who worked at the WZB. And it's also a learning process. No? So once you have like further people joining, they also tell you maybe we could improve on certain things. Then Hong wrote a nice chapter on best practices. And that's a very nice experience. And I think at the end of the roundtable, we'll also discuss a bit how, in what direction this project could proceed, how people could contribute. And one thing I would like to emphasize, and Dennis already said this, so we are the kind of current editors of the project, but this is really meant to be a very open thing so that everyone can contribute, that we can exchange these roles, and that the project continues if one of us kind of drops out for whatever reason.
Okay, so we thought that before we jump into the substantive presentation of some of the chapters and the discussion about opportunities and issues arising around APIs, that for the audience that we have here, it might actually be of interest to show you some technical details around how this whole book or project is set up. So to go to the next slide. This book is set up as a collaborative project using methods of work methods that have been originally developed by the open source software community. So basically, each chapter of the book is based on one R Markdown file, and the book is hosted by a book DAO which knits together all of these chapters. And the whole book, so all of the chapters, are stored as a public repository on GitHub. And could we maybe quickly switch to the GitHub page or to the yes. So here basically you see the code that is underlying the book project that you see online. And if you click on one of the markdown files, you basically see the code that is the markdown file that is underlying and the R code that has been written to interact with the API. Okay, could we go back to the slides now?
That could be a little more difficult.
Oh,
Okay. Give me a second.
sure. So essentially, the message of showing you the GitHub page is really, this is why it's open source. This is why everyone can interact and adapt the chapters and everyone can contribute, right? Yeah, this was the message of showing you GitHub. Exactly. And now I quickly wanted to introduce you through a couple of challenges that arise in such a collaborative project. One more slide. Yes, one back, please. Okay, so the first issue or challenge is authentication, yeah, and it arises around the question: so how can the different authors actually push self-contained or markdown chapters that are reproducible themselves to GitHub without exposing their sensitive credentials or authentication information? Yeah, so for many APIs, in order to actually retrieve or query data, you need to authenticate. So the issue is, how can they push replicable, reproducible chapters without exposing their information? So I think Hong has done quite some consulting here, and there are different solutions arising. One is, for example, to store your keys, so your authentication details, locally in a JSON file and authenticate through them, so the keys themselves are not pushed to GitHub. Another solution would be to use environment variables. So in R, you can define underlying environment variables that store information that will always be available to you when you start a new R session without needing to manually assign them, right? So there are different versions of how to do this, but you see one possibility here. So using the system set command, you could define some variable, for example, my secret. You define it as your key for a certain API. And whenever you load up a new R session, you can access the information that's stored in that object without hard coding or reassigning the object again using the system get information. So this was kind of this issue of authentication, how to produce reproducible chapters without exposing the details that the project has dealt with. And the second issue is reproducibility. And I think this has several dimensions. So the first dimension is, how can a reader that reads through a chapter now reproduce the R code that they are reading without needing to authenticate with the API in the first place, right? That's somehow an issue. And how we solve this is that, so a local copy of the API response that is generated through the code of each chapter is actually stored locally on GitHub. And so yeah, you can just access data through GitHub, which is closely related to a technique called caching, which Hong also wrote about in his chapter on best practices. And the next dimension on the next slide arises around the question that, okay, so if this it was so nice to have all of these chapters, but at one point we had 21 chapters interacting with different APIs publishing R code. And we asked ourselves, okay, so the R packages get updated all the time, which might come with changes in functionality. Our versions get updated, which might come with certain packages being incompatible with the R versions. And thirdly, the API functionalities themselves might get updated. So for example, there might be new access restrictions, or there might be changes in the rate limits, or changes to how much data can be retrieved from one API call or throughout a certain window of time. One thing that we do is we work with the checkpoint package, which is part of the reproducible R toolkit. So basically, daily snapshots of a CRAN are mirrored on a separate server. And if you execute the command that you see here, packages are installed in the exact version that they had been posted to CRAN when we did our last reproducibility check. Yeah? And the second thing, with which I'm closing,
is that we have implemented automatized reproducibility checks through an error control script, which you can also look at on GitHub if you want to. So basically, this script loops over all chapter files, extracts all the raw R code, and executes all R code that all the authors of the 21 chapters have written, and stores information whether any error is meanwhile generated as a consequence of some update of an R package or API that has been used, and also stores the error message. So if you go on the last slide for technical details, what is generated is basically a data frame that gives us an overview which chapter is meanwhile causing problems and which chapter is still running. And by executing this once a semester or once a year, we can kind of diagnose, are there meanwhile any problems in any chapter, or if everything is running smoothly. With increasing numbers of chapters, I think will become increasingly important. So,
actually, if I may add a point, so most, like I would say, 99% of the work that was done by Leon, so he took it up in himself, which is great. And I think in that sense, it's like this book or website project could also become an example for other kind of similar books that have that face the same issues that we are facing with this project.
Okay, thank you so much, Leon. Now, we have talked a lot about APIs and the technical background. I think it would be a good point that you see some examples of actual APIs we have and what the chapters contain. So each of us is going to talk rather briefly about their chapter or their chapters they contributed to the review. And I guess we will start with Hong, who contributed multiple chapters.
Yeah, I actually contributed 3 different chapters. So the Twitter one, and also the media crowd one, and also the best practice chapter. But yeah, for the Twitter one, actually it's very basic, which is you can get the data from the new Twitter 2.0 API. But the very important message in this chapter is actually that one. There are so many, if not too many, social science examples using this API, which is not corresponding to the popularity of Twitter itself. So the second chapter that I contribute is actually the media crowd. The media crowd is a collaborative project between multiple US institutes, and they scrape the media information from various websites, mostly via RSS. And so I wrote a chapter on this using the package Media Cloud developed by Uncle at the LMU. And the package also provides a function to pull the document term matrix from the Media Cloud, which is very useful if you want to do something like sentiment analysis or the text model, topics model. And then the final chapter that I contribute is the best practice chapters. And Leon has talked about the authentication information part, and also the memorizing the API call parts, and I don't want to repeat it. But the most important thing actually is you need to do your homework. And actually from there, you see that, okay, there's a little vignette about getting the data from the Media Cloud API. I highlighted one word, which is the Gewinnsituation, which is a German, right? But the Media Cloud use a stemma, which is for English, and that's why the stemma make an error. And you can actually find this kind of error from their documentation. For example, you can see that, okay, their documentation actually saying that they are using the same stemma for all the language, and it will generate the error that look like that. So very important, do your homework. Yeah, that is for my part.
Can I just say one?
Sure.
So I think why this chapter is so important, like the best practices, is that if you leak your API key, other people might use it. Yeah, so they might use, and then it could also create costs for you. You know, if you use some Google machine learning APIs, and then someone else might might play around with it. So I think that's really something to avoid.
Okay, thank you so much, Chung. I would say we go further to Lukas.
Yes, thank you. Yeah, I provided two quite different chapters to the review. The first one is the Google Places API, which is part of the wider universe of Google APIs. So you already heard of several of them, I think. Paul just mentioned machine learning APIs. So Google provides quite a rich universe of different APIs, which can access different options from which we know from our daily use of Google, but also offers access to machine learning algorithm, etc. And the Google Places API is just one API that gives access to some of these functions, which is focused on places, as is in the name. So provided services are a place search. So in this plot on the left-hand side, you can see a search for pizza places in Mannheim. And then you can also gather information on those places. And I think my favorite example, how it is used or might be used in social science research, is an example from Konrad in 2020, using the Google Places API to research changes in the mobility of people during the COVID-19 pandemic. So through this API, you can get information on how frequently different pizza places or whatever are frequented. And you can use that to research changes in the mobility of people. The second API I provided, or the second chapter I provided, introduces the Internet Archive API. I don't know if you all are familiar with the Internet Archive. The Internet Archive is an open source project where mementos of web pages are stored. So you can go there and check out homepages from 1996. From the 2000s and so on. So especially with bigger websites, which are frequented more often, there are a lot of different snapshots, often multiple snapshots per day for a website. And you can go back in time and look at how this website looked at a certain point in time. And so the Internet Archive API offers us accessibility essentially to the timestamps and URLs of these mementos stored in the Internet Archive. And as a bit of self-advertising, maybe the reason why I wrote this chapter is an R package I wrote myself together with Constantin Gavras, which accesses this API to gather information on the URLs or on these mementos stored in the Internet Archive, and which facilitates then the scraping of content from these websites or from these stored mementos. And one example is then from Constantin Gavras, who accessed online newspaper articles from a wide range of European countries via the Internet Archive. Apart from that, there are not that many examples yet, but I think another nice use case would be to check how parties, for example, change their websites after changing leadership or anything like that. Yeah, that's from me.
Thank you. And also, I think it's nice that we have an expert for this chapter because you wrote the package, so that's super nice. Thank you. Next, we have Marie.
All right. Yeah. So when I stumbled upon this Spotify API, I was pretty stoked because I'm quite the music fan and I already saw the opportunity to do something with it. I didn't know what, but I knew I wanted to do something with it. And I think you all agree that there is some potential in it. If you think about the parties in the last election that all had like their party playlist on Spotify to kind of signal something. And so the Spotify Web API allows you to easily pull data from the platform. For those who don't know what Spotify is, it's just one of the biggest music providers out there at the moment. And so what you need to do for that, and I think that's quite important, to access the data in the first place, you need to have a user account, and then you need to set up a developer access. So you have to have an account for that. You have to sign up. You don't have to pay, but you do have to have an account. And you can then access the data with a simple API call, or you can use the Spotify package. possible data requests that you can look into are generally divided into two parts. You can look at general data, so just data on track audio features, on playlists, on popularity metrics. So just looking into how do different albums perform, how do the top 50 in Germany or in the world change over time. But you can also look at your own data. Important for that, for the individual user data, if you want to use other people's data, you of course need to have their consent, and it's like a big process where they kind of take that they share the data with you. So that's to be kept in mind. And you have to have the account for a while, because if you don't have the account for a while, then you don't have the information that has on your listening behavior, right? So if you want to access your listening behavior from 6 months ago, you should have listened to some music 6 months ago, right? And you can see some simple track data on there on the top left, where you have some examples on what metrics Spotify actually collects. For example, the track popularity, which I looked into quite a bit because I was wondering, why does it not correlate such high in a higher way with the rank in the top 50 playlists worldwide? And it turns out that some of the measures that you see are defined by Spotify themselves, and they don't really tell you what goes into this. So this is important to keep in mind when you try and analyze stuff with it. On the top, on the bottom, you can see in the figure a visualization of the top 50 at the time that I scraped the data when Harry Styles released his new album. As you can see, with like the beige album cover, it's full with it. So how do we use it in social sciences if not by looking at the playlists by the parties and class selection? There are some interesting examples, and just tagging on to the COVID example that we had before, there was an interesting study that looked into like the top 50 playlists in countries and looked at how the mood changed over time. And they found that during COVID, when the vaccine got released, happiness of the tracks in the top 50 actually increased. But when Omicron came up, the happiness decreased. So I think it's just an interesting example of the traces we all leave in the internet that we maybe don't think about, but in the aggregate become really interesting reflections of what is going on in society. So yeah, not that many examples out there yet, but I hope that you might provide some. Thank you.
Right, and I guess we can move on then to the Reddit API. So, right, for those of you who don't know what Reddit is, so it's basically an internet page which has a lot of nested communities about certain topics. So, for example, politics, or like the most interesting thing on the internet, cats and other cute animals. So what you can get from the API is, well, pretty much text data only, but you can get some metadata. So for example, how many people liked a certain post, or what's the upvote ratio, for example. And the best thing about the API is that it's actually completely free to access to any individual user, except for people who actually want to make commercial gains. So if you want to write an app or a program that basically tracks users' data and tries to recommend them, for example, ads or something of the like, Reddit will not allow it, or you would have to actually get agreement from it, because they could actually sue you if you do that. So yeah, for data collection, really, I wrote the chapter using two packages. So one of which is HTTR, which allows you to collect like versatile amounts of data. So you can basically, it's akin to web scraping, and you can collect as much data as you want. But the bad thing about it is that you have to write a lot of code, and it's really messy data, as you can imagine. And there you can see in figure 1, so that's the raw output of what I got if I ran a simple call. And this is a really complicated list that has a lot of lists in it as well. And if you've programmed and worked with lists, I'm pretty sure you know just how annoying they can be. And figure 2 just basically shows all of the data that I was able to get from this list. So really, for HTTR, you can get a lot of flexible data, and you can get everything, but really it's really difficult to write some code for it, which is why I wrote the chapter with another package in mind, which is Reddit Extractor. And it allows you to get a lot of data, and very easily. It's going to be given to you in a nice, clean data frame. But the only bad thing about it is it's still kind of in development. So you have a lot of problems with it, whereas you can't collect, for example, time series data. Like you can't go back in time and say, I want to see what this user posted in 2020 or 2021, but you can work with time series data in this by running the command right now. So if you run it today and tomorrow and further into time, you can collect all of the data that you want for a certain day, a certain week, a month, or even a year, or all time, really. And here in figure 3, you can actually see the data that I got from the unpopular opinion subreddit. So you can read them. Some of them might be really weird to read. And that's like the cool thing about the API is that you can get a lot of interesting texts from people who don't know they are actually being observed, and they will actually share all of their opinions that they have. And yeah, which brings me to like what you can use it with. So I, as a researcher who studies like extremism and prejudice and the far right, I found that a lot of texts, like there is a really cool article by Godet et al. If you want to read those articles, you can find all the references in my chapter. And basically the authors use like text data from the Donald subreddit, which was basically a community of Trump supporters in Reddit before it got banned. More on that later. But basically, the researchers found that compared to random samples of these Reddit threads, like the most popular threads in the community of the Donald were basically about dehumanizing opponents of Donald Trump. So for example, left-wing people, Muslims, and people from other races as well. So yeah, it offers a lot of like a lot of opportunity to test certain things. And as I said, it has a lot of communities. So you can actually look for data about cats or whatever else you want to. And yeah, that's pretty much about it.
Thank you, Don. Okay. Yeah, we have one more slide with our own API. So Leon, Paul, and mine. And I think we have some time to give a quick overview. Yes.
So Tilmin Stöckler and me provided a chapter on a CrowdTangle. So CrowdTangle is a public insights tool that tracks social media content. It was founded in 2012 and it became big so rapidly that Facebook, or now Meta, was taking it over in 2016. So what CrowdTangle is doing is it systematically tracks the posts and the interactions and engagement with these posts of public pages, groups, or verified public persons. Yeah. So only public entities across Facebook, Instagram, and Reddit. They used to also track it for Twitter, but then shut the service down, which I think is an interesting example of provider dependency that we're going to touch upon in the discussion. Essentially, it's not open for everyone, only for Meta partners, but researchers can apply for access. And the nice thing here is that CrowdTangle is updated every 15 minutes. And you do actually get the data in time series format, but only for public pages or verified accounts. I'm not 100% sure how that relates to Reddit, actually. Probably like the most successful subreddits are tracked, I think. So yeah, there are very interesting examples of research pieces that have been published with this. For example, there were people that showed how a conspiracy theory that related the COVID outbreak to the rollout of 5G technology in Wuhan spread across social media. And another paper showcased how right-wing politicians are more successful in actually engaging with their audience in social media than left-wing or center politicians. So I think a really nice data source. So yeah. Feel free to use it.
Yeah, thank you. Last but not least, maybe very quickly about the 3 chapters that I wrote together with Bauer and also with Malte Sohnius, who's no longer at the University of Mannheim, but he joined back then. So we were concerned with 3 Google APIs. The first one is the Google Natural Language API. Then we have the Google Speech to Text and Google Translation. Yeah, I guess the speech to text and translation is clear. So speech to text does conversion from speech to text. We are actually using it right now because we collected audio data in a survey and now we can translate it to text. And it works quite good. It works with deep learning. and you have over 100 languages which are supported. The third one was the translation API. So I guess you are all familiar with the Google Translate tool. The API is way more advanced since it works with other training data. Yeah, if you have larger sets of data needed to be translated, you could have a look at the API. Maybe most interesting is the natural language API. So here you can do all kinds of different tasks with text data. What Google does here is that it provides us with pre-trained models for natural language processing. And you as a user could either provide unlabeled or already labeled data. And then you have a bunch of different services. So we have sentiment analysis, we have the named entity recognition, which I already mentioned. We have syntax analysis, which is similar. So for instance, for one presentation, we had text data, and then we identified only the nouns in the corpus to show the nouns, or only the verbs and so on. I guess these are a bit different because they are more about, I would say, data manipulation. So it's not for data collection per se. I mean, it depends on how you define data collection, but basically they are more about transforming and manipulating the data. But they are very useful. Yeah. You can find all those chapters in the book. And I guess right now we have about 21 chapters, so quite a variety. I think we here have kind of a focus on social media APIs, but there are also all kinds of other APIs in the or on the website. Do you have any questions so far? Any comments or things you're curious about?
Just related to the Facebook-centric APIs. So I noticed in the book that it does mention that you must be a Facebook partner to access probably a lot of the features, and I have heard that it's pretty difficult to get access to that. So I was wondering if anyone who's worked with that at Mannheim as a researcher had experience with actually getting access to those APIs, because it's sort of infamously difficult.
Has one of you worked with Facebook?
I can maybe say something for Roundtable. So it is becoming increasingly more difficult, I think. They have been pretty liberal in the past. So now, basically what Meta did is it clearly defined a range of research topics that you are allowed to research with the API, right? So if you apply for granted access and you want to work on the spread of misinformation, you have a good chance to get access. If you want to work on elections, you have a good chance of getting access, and COVID as well. But other research topics will simply be rejected, which essentially creates two classes of researchers, right? Those who work on topics that Meta deems interesting and those who don't. But yeah, if you are on researching one of these topics, I think getting access is possible, although yeah, it has been handled increasingly at least by Roundtable.
Okay, I didn't know that about that updated situation. That's very interesting. Thanks.
Okay, so now what we are doing is jumping into the discussion I advertised. So what we did is we came up with some questions we want to mainly ask our panelists about. And the procedure is going to be that I ask the questions and then name some of you where I guess you would be very suitable to answer the questions. And yeah, it's open. So please, we are free to jump in. We can all, if you have a comment or if we want to contribute something, also for the audience, jump in. And otherwise, we let our panelists talk first. Right. Very basic start, which we wanted to talk about is typical use cases. I mean, you now saw some examples, but I was thinking of very unique data that you could get via APIs and not so much about more traditional methods of collecting data. And maybe to start with Marie-Lou and Dom, maybe you could say something about it.
Me to start? Yeah. So basically from Reddit, you can get text data, which wouldn't be something new for many researchers. However, what I think like is really cool about it is that it doesn't suffer from like what's called the Hawthorne effect, which is basically when people know they're being observed in lab studies or in surveys. So because it's been shown in research that people will act differently and like when they are being observed. And when you load up Reddit, usually most people don't know like that they would be observed by researchers, right? So again, to reiterate the example of the Donald subreddit, like it was so toxic, basically, I think, because a lot of the people were in these communities and because they thought that no one was really watching them, no one was really going in, or like the only people that would only see their posts on the subreddit would be people that were actually supportive of Donald Trump themselves and who basically like shared similar opinions. And the thing is that it provided very useful data because it was to a large degree very like dehumanizing data or dehumanizing text about people, and which is what got the subreddit banned, but not before giving researchers who already had collected data before that like a unique insight into it. Because I'm pretty sure that in surveys or in experiments, like when we have social desirability bias to not express unwanted things such as racism and discrimination, you wouldn't get people in surveys to just say, oh yeah, this group X is like subhuman or whatever. And on Reddit, you actually had that. So this is pretty unique and interesting data, I would say.
Yeah. So, I mean, the opportunities of how to use APIs are various, right? And just recently, I've been working in a project where we are using the Twitter API to scrape thousands and thousands of tweets of people and their liking behavior and retweet behavior on the basis of certain keywords to try and figure out whether they would suit in our sample. So I think another way of using APIs in a less classical way is to also think about our sampling in a different way, right? Where do we get people from that we interview? And especially if we're interested in debates that are taking place online, then why not actively engage with the people that are in our samples and survey them, right? So this is one example, and the other one, you know, I kind of tapped into this is with my Spotify chapter. There are so many different behavioral implications of what we do and how we feel, and I think this is just in the beginning. Just recently, we had discussions when we were at the lunch, and we were talking about how we might connect behavioral data on Spotify with people's political opinions and look at whether maybe with certain ideologies you are more tempted to listen to certain music and listen to other artists if you have a different opinion, right? So I think, yeah, there are many opportunities and interesting objectives beyond the classical text corpus of tweets.
Thank you. I also put one snapshot of a paper here because I actually think it suits very well. Oh, could you go one slide further? Thank you. I was thinking of you too because I thought social media data in particular is something you could only get via API. So it's a very unique kind of data. And there is also some theoretical work about it. So here they are talking about how social media data is process generated. So it's very unbiased. So you have no, as Dom put it, like it's very rare data. So yeah, if somebody is interested, you could have a look at that paper. I think it's suited the answer from very well. Maybe you two would also like to make a small comparison to more traditional ways of collecting data. We have also here a question about it. So how does data collection via APIs, like in the aforementioned examples, compared to more traditional methods of data collection?
Yeah, so I think one factor that you always have to keep in mind because I was talking about the sampling before, right? What is the sample you're looking at? And what is the population you're making inferences about? And with using APIs, if we stick, for example, with Reddit, right? I have a Reddit account as well. that I am what we would call a lurker. I never upload anything. I never engage with anything. I never post anything revealing. I'm just using the app to read what other people are doing. And I would not be a non-sample, no matter what I did, right? So we need to keep in mind that we only collect data from people who are active on these platforms in any way, such that we can collect any data from them. And in addition to that, we also need to keep in mind that the data quality might not be the best, right? So if we want to use, say, Twitter data to make inferences about the general population, then this will not work out, right? So we need to kind of have a look at when are we collecting data of whom on the basis of what keywords or whatever, and what can we really say from what we collected.
Yeah, so now that you've been railing on the APIs, now's my chance to defend them. So like the good thing about them is that basically everything's automated. So you know, when you're running a survey experiment or a lab experiment, you actually have to get a grant usually and hire a bunch of student assistants. Here, you only need one programmer, and if you're good enough, you can be that programmer, or you can hire just a few people to do all of the programming for you, and you have all of the data that you want, like literal terabytes at your fingertips. So everything's automated, and everything, like you can get a lot of data, which of course, via traditional survey research, if you would try to get that much data, you would take tens of like hundreds of years probably, which is longer than most of our academic careers go, I'd wager. But yeah, and I also think that there's like a few obviously drawbacks, and that, for example, using the Reddit example again, that all of the communities, for example, suffer from a lot of self-selection bias, because of course, those communities are usually going to be more insular. So for example, you're not going to go into the cat subreddit just because if you really like dogs and you hate cats, right? Usually people don't do that. So these communities can risk sometimes becoming echo chambers. So you will have an even like worse sample than like a simple random sample, and you will not be able to get good data if you actually want to have random samples. However, if you want to test stuff like a polarization between communities, or how communities can become insular and create different language, Reddit is usually very, very cool. And I don't think with survey research that you can actually get people into these communities naturally, at least. So yeah, I think Reddit, for example, provides a lot of like natural data that you would not be able to get from survey research.
So I'm bad cop again. But the reliability, I think the problem is, right, if you do a survey, you know what you want to know and you know how you're going to ask it. And when using APIs, you don't have control over that, right? Because other providers, other websites collect the data for you in a way that they want to collect the data. And this also means that it's not that reliable. And this, for one, taps into this field that Leon talked about before, like how to keep the chapters running. Do the commands change? Does access change, right? But it also means that the data you have access to and the command works well is maybe pre-filtered, and you may not see everything that is there because it has been put up before. And also, because I just had this experience a couple of days ago, we are running an experiment on Twitter. We're using the developer account, had elevated access, everything. And we stuck to the limits that they gave us, but there was a kind of arbitrary threshold that they blocked us anyway, right? So we stuck to limits of messaging, of following, and then in the end, we looked on the website and it said, well, but we may limit your account nonetheless on the basis of, and then they listed a couple of factors that, you know, they just don't put a number on it. For our example, we tried to follow accounts and they then said, well, the ratio isn't right of following and followers, but there was no way for us to determine when the ratio was right. We just knew right now we can't follow accounts, next day we were blocked, and then it was kind of like, yeah, well, but how high is the ratio? And then we looked it up and it said, this is individual, this depends on the account. So that's just to keep in mind that, you know, there is reliability issues there. You don't know what exactly is collected, what data you can see, and you cannot, you know, kind of personalize it to your own.
Yeah, again, I would say, oh, do you want to ask a question?
I just had a question on that, because that's really interesting. the license that you have for this Twitter API account, is it a paid one or is it paid for by somebody?
No, it's elevated access. So it's
Okay.
just, we had to apply with like our research project and everything. And then
Yeah,
we get
I'm
the
just
access.
surprised that they can do that to you, even if you're kind of
Yes, yeah,
someone
yeah.
who's got an agreement with them.
Yeah.
But yeah, okay.
Yeah, a short thing that I just wanted to add is this access is usually like quite variable among different social media platforms. So for example, like Twitter might be, because it's a bigger company, it might be restrictive on a lot of things. Reddit, for example, again, to go back to it, doesn't do that. So you can get pretty much anything right now, unless you're a commercial user. However, like they try to impose other limitations, such as the calls that you can make. So you can collect, like you can only do one call every 1 second. So you can only like get data every other second. So if you're interested in microseconds and comments, well, Reddit, for example, wouldn't be for you.
Yeah, and I think one last part, if you think about how you set up a server usually, right? You have some kind of consent form that you craft, you maybe go through an ethics committee, send them the consent form, they say, that's great, you show it to the respondent, they sign it. With APIs, it's different, right? And that's what Dom said, that is great. People don't know that they're being sent because potentially there might be in the sample sometime, but they don't know, even if they sign it or agree to a certain terms and conditions when they sign up with their account. And so it's rather an ethical question to think about when people consent to data collection, and this might differ by country, right? In the EU with the GDPR, we might have different regulations, but also in my experience with the IRB in the US, it's quite a different thing. And there is PII, there's identifiable data in there of real people, and you need to keep that in mind when working with APIs.
So I just wanted to chip in. So there's this really nice book by Salganik, Bit by Bit. It's really recommended a read. I think he was one of the main people who introduced CSS methods into sociology. And he has this concept of found data, that basically this kind of data is found in the sense that it's not designed for a particular research question. And that's kind of a concept that's really useful, I guess, in thinking about this data. Yeah. With other data sources, either you collect the data yourself, so it's kind of designed for your research question, or if you get it from some survey organization, they also often had questions in mind. Here, that is often not the case.
A good question, more related to what you spoke about, the limitations of the access to APIs. Something I find quite challenging sometimes, I'm not sure if you have some input on that, is related exactly to this API calls, like the limitation that impose on that, or even that you do not have the time series or historical data. So my question is, do you usually have to adapt to these platforms, to what they provide, or is there a way that you can make a system to which that you can, I can automatically collect data every day because I'm not able to pull all the data that I need at once or something like that. So is this, did any of you work with something related to the process of dealing with the limitations in terms of extracting data from the API?
Yeah, I mean, for example, to use the Twitter example, you can use something called the REST API, which basically you can pull stuff from the past. And you can get into these, like you can work according to these limitations, where you just basically write automatic code that, okay, pull this data. And if it, for example, if you get like a warning message from Twitter, because Twitter isn't that like bad that it's going to just ban you the first time you violate it, it's going to give you warnings. So you can write an algorithm or a function that basically tells it like to itself that the rate limit's been breached and like reduce it or wait for a bit. So there exists technical ways to go like integrate everything with the rate limitations. Yeah, I hope that answers your question.
Maybe I can add to that. Basically, all these APIs have limits on how much you can ask of them once at a time, just because otherwise you block all their internet connection at once. They don't want that to happen. So usually with all these APIs, especially if you want to get larger amounts of data, what you would do is to split up your call into subcalls and then have an algorithm wait for a few seconds, maybe 10 seconds, maybe 1 second. so you do not overuse their connection at once, because if you do, they will usually just block you, not allow you access.
Yeah, maybe one experience I had, so sometimes there might be gray areas. So for instance, with the Twitter rate limit, if you're a team of 3 researchers, then in principle, you might be allowed to use the free kind of Twitter accounts. No? So then you have the limit times 3, so to say. So there might be certain options, but I guess generally it's recommended to really look at what are the rules, no? Because you're basically don't want to taint your reputation, or you want to continue to do research. You don't want to be basically thrown off the platform for the rest of your life.
I can give you a more extreme example, which is I was working in a project called the Weiboscope, which is monitoring the China social media. And for that project, I just want to get all the social media posts that has been deleted. And of course, you cannot get those information from the API per se, but you can get it, like, for example, get a snapshot every 15 minutes. And then using the diff command to find out which message has been deleted. And then, so this is somehow what we're trying to overcome the API limitation to answer our research questions. But at the same time, we are not so sure whether or not this method is ethical. And yeah.
Yeah.
There's another question on the chat that I'd read out if you don't mind. It's from Chung-hong. And the question is, how would you respond to criticisms against the black box nature of data analysis or data transformation APIs, such as the Google NLP or Translate APIs? And do you have any suggestions on how to deal with these criticisms?
Yeah, sure. Maybe I can talk a bit about it because I use those Google APIs and we got a lot of the same criticism at conferences and so on because of the black box approach. I think we haven't found an answer yet. For sure, there's a trade-off between performance and documentation. For us, for our text data, the Google APIs simply work very well. But of course, depending on your research question, if it's very important that you exactly know what happens, especially if it's a very main outcome or even independent variable, I guess you would have to encounter a lot of questions, which you cannot necessarily answer. But on the other side, I guess it's mostly about the Google APIs because they are very keen on keeping their secret about the algorithms. Other APIs, I guess, are way better documented and also have, maybe they provide some more insights, but yeah, it's a larger topic.
Yeah, and I think it's it's a huge problem. And if, I mean, we have like a very good trend towards reproducibility in science. So I guess one ground rule for at least that I think we try to use is always try to find an open source option. You know, so if you want to use a certain machine learning algorithm, maybe you can find an open source version of it, and then if that works well, you kind of use that because you can look into it, and then there might be certain problems in your research where you actually can't resort to that. So I think another example we had is where we're transcribing audio data. There's actually some open source machine learning libraries to do that, but then the quality wasn't as good as kind of the Google product, and then we resorted to the latter. No? But I think in general, you should have the objective to that everything is open, basically, that you're using.
Yeah, that's what I was meaning, kind of, because the transcription, I guess, is nothing where it is bad if you have a black box, because if it works, then it works. It's not so important for us how the transcription works, right? So this is maybe more about the data manipulation APIs, as I call them, and not the data collection APIs. So where you process your data, maybe it's not such a big problem.
unless we have a question in the chat. But with regard to the black box of Google Translate, to what extent is it black box? Because I mean, they publish a bunch of things about roughly how it works. We know that it uses BERT for its transformation space, and we know a few things about the neural network and how it's supervised.
Yeah.
So, but yeah, just wondering how black box is this? Is this black box?
Yeah, very good. I think it's two kind of black boxes. The first one is what do they use? So it's BERT, for instance, which is very nice if we have those informations or this information. And then the second one also maybe goes into the direction of such things as explainable AI and so on. So where we have to explain to readers and editors and so on what happens in BERT, for instance. But this is a different problem, of course. Yeah. So I agree with you that if you really want to, you could get information on how the transcription works for the Google API.
I mean, you like would know about the fundamental technology, kind of like what kind of basic models they use. But I think it's very black box in the sense you upload some data, then you get a data response, for instance, with the transcriptions. And I think like the problematic thing about it also is if then maybe 1 or 2 years later, someone tries to reproduce your research and maybe tries to transcribe them again, no? Then the kind of the technology that you've used back like 2 years before may have been updated and they might get different results, you know? But you can't, like I guess in an ideal world, you would basically upload all the code and the data, and then people are really able to see all the steps and what happened exactly, but it's not possible.
Is it also a problem with reproducibility in terms of like a lot of the data that you get from say social media APIs, there's restrictions on whether you're allowed to potentially store it because someone could update their privacy settings and you need to make sure that you're getting the latest. So if someone 10 years later pulls in that data, then you know the people might have deleted their account since then, so the data's different and now the outcome's different. So is that also a replicability challenge that's sort of experienced by the researchers or not so much?
Yes, I mean, does anyone else want to? I mean, my like short experience, for instance, for Twitter data, you're only allowed to publish the IDs of tweets, but not really like the tweets themselves. Yeah. Obviously, that's kind of a challenge. No?
Okay.
And maybe like in private, you can then share the data with someone who wants to replicate you.
Yeah.
But you cannot make it public, which I think is unfortunate. No?
But I didn't know you can publish the ID. That actually quite is helpful. So that's pretty cool.
Yeah, but then you might run into the problem that, as you say, you might try to get the tweets from using the IDs, but maybe they've been deleted in the meantime.
Yeah.
And then you don't have the same data set.
Maybe just one more note on that. I think some of these issues basically derive from the fact that usually these APIs have not been or have been developed for commercial purposes and not with research in mind, right? So I think some companies have now allowed researchers to share their data during the review process, but not upload it to any kind of database, which then excludes you from publishing in many of the top tier journals, right? So yeah, this is just an issue that in general, these are commercial products, which now just step by step are finding interest into the research area as well. But yeah, I think publication of data is definitely an issue.
That's a good answer.
Maybe a little bit forward to that actually, because I was wondering about the ethical implications of it. And I see like multiple scenarios where I'm worried about that. And one of them is like they don't know that they're being monitored, which is good for data to reflect data quality. But at the same time, they didn't really consent to it in that sense. And I know that the GDPR has like this exemption for like if it's for scientific use, you can do pretty much whatever you want with the data. But like legally, so you're kind of covered, but I don't know if it's like ethically, there's still a justification. And then secondly, I think you can also change behavior in those communities. Like if you follow people, if you post stuff on Twitter yourself, or if you start a subreddit yourself because you want to like conduct an experiment or whatever, then you monitor that. So you change basically through interaction with people, possibly. And then thirdly, that's why I just clicked onto this stuff about reproducibility aspect, I was wondering if you actually publish the data, how can you make sure? Because, for example, with Lukas API, that is for scientific use. But if you publish data from like older versions of web pages that people have changed because maybe they wanted the information gone from there or something, and then you publish it, how do you control that this is actually the other people that use it will use it scientifically and not just like scrape email addresses or something and send out advertising? So I think like there's a lot of moving parts ethical wise. I'm not really sure how do you, like, when you develop an API or when you use it, how would you weigh that against, oh, that's a cool project I want to do?
First thing first, if you would use APIs, you would have to get ethical approval by the university. Yeah, which is a whole topic for sure. Yeah, that's just something to keep in mind. You cannot probably not simply get the data via the API and then publish it. Ethical approval would be advisable.
The second point I would suggest is that usually using APIs, what we're doing is essentially just taking publicly available information. So if we look into these Reddit forums, for example, then there's a publicly available information, and everybody with a computer can go to Reddit, can go to the Reddit page. Usually you don't even need a Reddit account yourself. You can just go to this forum and see all the content. So I think you can make an argument that it is ethically appropriate to also use this information scientifically. Gets more difficult when we look at all these changes in time, etc. So if we think about people having the right to maybe alter information they provide on the internet, the example you gave with someone maybe having put up an email address on their web page, did not realizing it and later changing it, but this information is stored forever on the internet because of the Internet Archive. Those are definitely problems. Yeah.
Someone else wants to chip in?
I mean, in regards to ethical issues, like some of the pages, for example, Reddit, like when it was created, it was envisioned to be like this free speech platform where everyone's like very anonymous, and that still remains to a large degree these days. Like if you have a username, for example, that like has some personal details, then of course, like you could probably identify that person. But when you sign up even for an account in Reddit, you don't have to specify like your gender, your race, or whatever else people might deem like important to track you down. So really, like the only way, for example, like ethics could be breached is if like you put something personal in your online handle, which I'm pretty sure like who would do that really?
Yeah,
so
sure.
I guess like one recommendation would be also that you kind of try to think of how your data might be misused. Like to give an example, so I'm collecting Twitter data from politicians. Now, even if you basically update just the tweets, the tweet IDs, yeah, with timestamps, and then you publish the data, one application could be that you basically try to estimate how long these people sleep. Now, because some politicians, they use Twitter without really being aware that this is all public and can be downloaded. And then some of them use Twitter like a messenger, so they kind of start early in the morning and end late at night. So in principle, you kind of can deduce the secondary information. You know? And then I guess you need to be creative and try to think about how could this be misused. And another thing is you could also decide not to publish kind of individual data, just in aggregated form, and somehow put the individual data set that needs to be used to replicate your stuff behind a wall or barrier. No? And I think it's kind of started that on these Dataverses, Harvard Dataverse, I'm not really sure, but you can basically gate the data. And then once there's a researcher who writes you an email, look and want to replicate this, then you can share it with them, but it's at least not kind of public. So there might be options there.
Okay, we have like 10 minutes more left. I thought maybe we can talk about one more question, and then maybe you also have some more final questions you want to ask us. To make this maybe the last question very hands-on approachy. So Hong, you wrote the best practice chapter. I wrote this one question here. Are there other dependencies or rules we have to consider when we use those API services? I
can say a little bit about it. So I think there are some drawbacks of using those API. And one of the most important drawback actually is that those API are mostly provided by commercial entities. And those commercial entities actually have all those data. And the data that they give you are actual proprietary data. It's not some data that you can share freely. So those data you can only be shared or even use according to what they want you to do. And so if you use that data, you need to know this point. And there are lots of cowboys out there who get all those Twitter data and then upload all the things that they have, which is brave, but at the same time, it somehow breached the ethical guideline. Actually, okay, answering your question. Actually, there is a internet research guideline published by the AOIR, specifically talking about the way how to get informed consent, or when we can waive the informed consent when we use the APIs. So I think we should follow that. And then there's also other problems related to the proprietary data. For example, there are some proprietary data provided by the platform, but they are not complete data. So they will just give you what the data that they want you to have. For example, like the fire hose. So it just gives you the most important one. They call it the most important Twitter data, for example. And there are lots of study talking about how biased are those selected data. So you also need to keep in mind that the data provided by the platform are not random sample, for example. So, and then regarding the ones that we use it for the algorithmic decision, for example, like Google Translate, or I don't know, the face recognition API, for example, we need to know the accuracy of those algorithms in one hand. Another is whether or not those accuracy is stable over time. For example, like the Google Translate API a few years ago, when Molly Roberts published a paper about the Google Translate API, she said that the Google Translate API cannot translate the name of Edward Snowden, for example. But if you use it now, of course, it can translate the name, but the API, the interface, actually doesn't change. But what is going on the server change. And that creates reproducibility issues again. And then, of course, there are also fairness questions. So for example, like the face recognition API, there are lots of study about how fair it is. For example, like, it cannot recognize the face of the Black people more accurately. And so it is not creating, okay, if you're talking about in the measurement error sense, it is not creating an error that is random. It creates a differential errors. So, and it is difficult to adjust for this kind of differential errors because in most of the time, we don't know how those differential error operate in your data unless you really try to audit these kind of algorithms. And luckily, there are lots of researchers now trying to audit this kind of algorithms, but I would say that it's just a beginning. We still have a lot to do about it. Yeah.
Thank you. Maybe for that very last slide for today, and to make a bit of advertisement for Markus Conrad, who is not here today, we have one more. So we have a lot of more slides, but no, it's the one that looks like this. I think it's one more. Yeah, perfect. Thank you. If you are interested in all those topics around accuracy or measures with API, so this one is about the genderized API, which assigns gender to names in data sets. Go ahead and check out the WZB data science blog. Markus Conrad, who contributed one chapter, wrote a very nice, I think, blog post about accuracy in using APIs and other cloud services, and this taps some of the topics Hong talked about. So you can find it online. Otherwise, I would give you the last opportunity to ask questions. We have 2 or 3 more minutes left.
How many of you have worked with APIs? Okay.
4 or 5.
If you don't have any questions in the audience, I would maybe like to throw in 2 questions of my own. The first being to the team, especially the editors. Are you still lacking any APIs, and do you want to procure some future co-authors, either on site or online here today?
I can say something about this. So the Bundestag has recently released an API. So a couple of years ago, those that have been working on legislative politics know that we have all been scraping this interactive website with Selenium. And I'm not 100% sure if everyone actually got the same data out of this, to be honest. So now there's an API, but it won't start. So yeah, we don't have a chapter yet. Maybe that's a nice opportunity.
Has anyone looked at Face Plus, which will take a photograph of a face and then return to you like the ethnicity, the age, data like that, gender, stuff like that on a photo?
Yeah, I mean, this goes into the genderized API a bit, but it's only about gender and it's text database. So, of course, images are super interesting.
I mean, in general, we would be really glad. So if some of you are interested in writing a chapter, you come forward and just send us an email. And sometimes we also get other people. So we have kind of a list of kind of potential APIs that would be interesting. So we could also kind of choose an API for you. If you kind of want to say, this is an opportunity to write a chapter, this, but obviously that would be great. And I think by now we also have this quite efficient onboarding process, so to say, where we have kind of the information structured and yes.
Yeah, so yeah, if you're interested, go to the README section of the GitHub repository. You can find many details there.
Second, and I guess last question for today. We've talked a lot about APIs for those big platforms, those big data providers that we can access using those existing APIs. Do you think in the near future, researchers will write their own APIs to make information that is gathered as part of their research endeavors available on a rolling basis, updating as we speak?
Almost shaking.
Yeah, okay, my answer to that is no. Yeah, don't do that. So if you want to share data, then just share the data to everyone. Don't deploy it as an API if you are a researcher. So I'm saying that because I have a specific example in mind, which is the photometer. So they are researcher and they deploy their algorithm on as an API, which is completely unnecessary, I would say. They can just release their logistic regression model to all of us to use. And it is waste of our time, waste of their computing resources, and actually is making their algorithm a black box unnecessarily. And so I'm completely against it.
So
okay.
So is there like motivation to Is it the motivation to keep the algorithm to themselves? So
I think so. I think so, but science shouldn't be work like that, right? Yeah. So even for example, like a translation API. Okay, they're actually, for example, like some people release Opus ML to the world. Even Google can release their bird to the world. Then why do you want to keep your fraud detection algorithm as a black box? Which is stupid.
I mean, maybe one example where it could be useful, like imagine that kind of your data is just too large, and let's say maybe you have millions of observations, and then kind of you can't just upload it for them to download it. Then maybe, I don't know, an API would give the possibility to get a subset of the data. Like
that may be a useful case, but not as but for the algorithm, no.
Okay. So
we have one more question in the chat. I know we're running out of time, so if you could very briefly respond to that. The question again from Chung-hong is, can you speak a little about API quality, the process of auditing and validating APIs before using them in research? There are many APIs. How do we know which ones are good?
I mean, just a short example. So for instance, for the transcription API, so we could basically would upload your audio data, and then you get the transcription from Google. And then you could decide, okay, for 100 cases, I basically go through manually, or let's say for 1,000 cases, and basically see how well it's kind of, you would evaluate the accuracy of this API. I'm sure it's not from our, I don't know if there's others.
Yeah, I mean, this is kind of the gold standard we were always talking about. It's good if you have a gold standard data, and for social scientists, this most often is manually coded data. And then you could compare it to a small subset of the API results. Yeah, just as an example. Any more comments?
I think for some, it's also maybe a limitation that you just have to acknowledge, and you have to kind of discuss. No, I guess if you have the feeling that Twitter says that they give you a random sample, but that somehow it's not random, then maybe you kind of your suspicion, you just have to discuss it and think of the implications it might have for your research.
Okay, so given that we're already over time, let me take this opportunity to thank the chairs, Paul, Leon, and Camille, especially Camille, for today's session. Thanks to our panelists, and thanks to our on-site and online audiences. This was super informative. Thank you so much for this great overview and the great discussion. And the Social Science Data Lab will be back in 2 weeks, October 5th, at a rather unusual time, 8:30 in the morning, because we will have to bridge the time difference to Australia, because Eric Wang will be presenting his work on matching methods for causal inference using time series cross-sectional data. Thank you all for being here today. Hope you will be here or tune in next time, and we'll see you. Bye-bye.